Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it is considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called A Square Green Ring by Megan33. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. We have adjacent digits along a green German whisper line must have a difference of at least 5. And I call these lines whisper 5 lines, not because of I'm trying to take credit or anything, but because it makes a setter basically labeled these as Whisper 5, and I think it made a lot of sense. Because you can extend it to other types of lines, like Whisper 6 lines, Whisper 3 lines, etc., etc. So when I say Whisper 5, know that it means also German Whisper. It's basically the same thing. Anyways, as an example, say we had a 3 on this Whisper 5 line, / German Whisper line. Then that would mean this would have to be an 8 or a 9, because these digits must have a difference of at least 5. And the only digits which can be 5 or more away from 3 are 8 and 9, which is why that would be 8 or 9. And that's an example of how a Whisper 5 line works. We have digits along a magenta Ren band form a set of consecutive non-repeating digits in any order. So for example, you could have something like, say, 6, 4, 3, and 5 here. And this would be valid because they form a set of consecutive non-repeating digits, right? 3, 4, 5, 6 is consecutive with each other. What cannot work is something like 2, 4, 5, 6 because those are not consecutive. And you can't have repeats also on the Ren band. So that's an example of how Ren band works. And finally, we have the digits along each arrow must sum to the digit in the circled cell. So, for example, say we had a 1, a 3, and a 4 here. That would guarantee that this digit has to be 8, because 1 plus 3 plus 4 adds up to 8, and the digits along the arrow must sum to the digit that's in the circle that it's attached to. So that's an example of how arrows work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So here we're going to use Fichte-Mathieu's ring theory because that's what this puzzle looks like it's set up to do. And Fichte-Mathieu's ring theory is basically that these 16 cells must be the exact same digits as the cell in every 2x2 corner. So that would basically mean that these cells here all are exactly the same cells as the cells that are surrounding the central box, which is here. I won't get into the proving of that before, because I've proved that a lot, particularly in the Let's Learn How to Sudoku, or the Learn How to Sudoku series. But basically, you can go to any one of the ones where we have a ring theory puzzle, and I will basically show why this is the case. So, anyways, since we know that these are exactly the same digits, we know what these add up to. We know how many of each there are. So, there are 4 definitely high digits here. We are guaranteed. Also, anytime you have 3 unique digits adding up to another digit, summing up to the basically what one digit is, you know two of them must be from 1, 2, and 3, right? To add up at least two of them, sorry, I should say. So 6 can be the sum of 1, 2, and 3, which means there are 3 digits from 1 through 3 there. 7 can be the sum of 1, 2, and 4, obviously 2 digits from 1, 2, or 3. 8 can be 1, 2, 5 adding up, or 1, 3, 4 adding up. So therefore, 8 can be the sum of, has 1, 2, or 1, 3 in both of its sums. And 9 can be 1, 2, 6, 1, 3, 5, or 2, 3, 4, obviously requiring 2 digits from 1 through 3. So, what does that mean? We are guaranteed, then, 6 digits from 1 through 3, and 4 digits that are from 6 through 9. 5 can never be on a Whisper 5 line, because if you subtract 5 or more from 5, you get 0 or less. If you add 5 or more to 5, you get 10 or more, 9 of which are normal Sudoku digits. On a Whisper 5 line, you'll always alternate between low and high digits, because if you have a low digit, what digits can be next to it? And the low digits are 1 through 4, the high digits being 6 through 9. 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can only be next to 9. So next to a low digit, you're guaranteed a high digit, and next to a high digit, it'll be the reverse. So, um, okay. So we're guaranteed if we have. So again, on a Whisper 5 line, you'll always alternate between low and high digits. So we are guaranteed on this Whisper 5 line, there have to be at least 3 high digits, right? Because again, you'll alternate between low and high. If it starts off low, you have low, high, low, high, low, high, low, which would be 4 lows and 3 highs. So you're guaranteed 3 highs in this set. Same with this. You're guaranteed 3 highs because, again, it's 7 in length. So you have to have at least 6 high digits in the 2x2 corners. Well, the only ones we're guaranteed are the ones in the circles. So that means we have to come up with at least 2 extras. And those 2 extras can only be not in the circles, right? Because the circles are guaranteed to be high. So these are guaranteed to be high. But we could have multiple lows here. But we need at least 2 highs in this set in the 2x2 boxes, because we need 6 highs to accommodate for the Whisper 5 lines, which must be exactly the same digits. So that means we have to have 2 highs here. So at least 2 of these are 1, 2, and 6, because those are the only highs we have available. But for 6 to be on a Whisper 5 line, they cannot be between 2 unique digits. I guess 6 could be here. So you could have 6 here and then 1 and 1 here. That is possible. So what happens if we try to have 6, the highs start on the outside? We would have high, low, high, low, high, low, high. Same with this, high, low, high, low, high, low, high. These don't have to be the same set though. But if we tried, so if that's the case, so okay, let's try to have 7 highs or 8 highs, which means we start having high here in one of these sets. So high, low, high, low, high, low, high. Means these would have to be sets of 9 with 1, 2, and 6 guaranteed. So that does not work. Actually, that could work. How does that... We could have 6 here, 6 here, 6 here, 6 here. That is possible. Okay, I was thinking that I was going to run into a contradiction there, but I guess not. For the 4-length Ren bands, it cannot be obviously all high or all low, because again, on a Whisper 5 line, you'll alternate between lows and highs, so you're guaranteed at least 1 high and 1 low here. So this cannot be 1 through 4, and it cannot be 6 through 9, because that would eliminate all lows or all highs in that box. We need 1 high and 1 low at least on this Whisper 5 line. So that means there has to be a 5 here guaranteed on this Ren band, and same here. This must have a 5. Okay. If we had a 6 here on these edges, you would guarantee this is 6, 1. I guess that works, actually. Dang it. Okay. That would force this to be 2, 3, 4, 5, and 2, 3, 4, 5. But that could work. Oh, hold up. Maybe I found something. Okay. If there is... So okay, we know that there are 2 other high digits in this Fistamifel ring. Well, specifically on the Whisper 5 line. If the 6s are here, so the only... Okay, hold up. We are guaranteed at least 2 other highs. So, and they have to be 6. So all the other highs are... So the other highs have to be 9 or 6 only, I think. if it's if it's 6 and these are 3 high digits on these whisper 5 lines, then the 6 has to be here. Which would force it to be 1 2 1 2 here. Sorry, 1 and 1 here. So if these are 6, if then we have the minimum of high digits, 6 and 6, these have to be 1 1 1 1. If we have a 6 on one of these edges here, so say we had well, right. The only high digits you can have besides the ones in the circles can only be 6, right? Because you can only have 1, 2, and 6 adding up to 9 in that instance along the arrows. There can't be any other high digits on the arrows. So any extra high digits must guaranteed be a 6. So you have to have, if you have three extra high digits, so that would mean this is high, low, high, low, high, low, high. These would have to be 6 here, and this would have to be 6 here. So then you would have, okay, you could have 6, 1, and 6, 1 being there, and this is 6 with 1 in there. So that means your guaranteed ones have to be with these arrows, in these arrow sets. And the problem, 6... Okay, yeah, the problem with having 6 at both edges, so you can't have 8 6s available. Or sorry, 4, you can't have 8 highs with 4 of them being 6s because that would force us to be 6 6 6 6, which would guarantee 1 is here and 1 is here, right? So that's not allowed. So you can either have an extra 3 6s or an extra 2 6s. Either way, if you have 6 being here and 6 being here, then this would have to be 1 here, 1 here, and then you would have to have 6 here with 1 being here and here. So you're guaranteed 4 ones on the Fistmafil's ring, which means they must be along the arrows each time. Or if you have 6 being here and 6 being here, then that would guarantee 1 here, 1 here, 1 here, 1 here. So you could have an extra 6 along there somewhere. We just know that in these corner boxes, specifically the corner 2x2s, you have to have a 1 guaranteed. Which means you must have a 1 somewhere on these Ren bands in boxes 2, 4, 6, and 8. So you're guaranteed 1 here. 1 cannot be on the end, because if 1 were on the end, we know there's a 6 somewhere along these. So either 6 is at the end or 6 is here. So 1 cannot be here. 1 has to be one of these two, 1 has to be one of these two, and 1 must be one of those two. Okay. Hmm. Um... what does that mean? I'm not sure. We're guaranteed 1 here. If this is 6, that's fine. You could have a 5. Hmm. You could have a 5 along the arrow as long as the 5 would be here, one of these two cells. Okay. That doesn't help much. Hmm. What you cannot have is 4 sets of 6, because then that would force this to be 6, 6, which would force 6, 6, which would force 1, 1 here, and that would be a contradiction. Um, mm, hmm. You need at least 2 6s that are extra, so that's guaranteed 9. Oh, and you can't have more than 2, you can't have more than 4 9s here. Okay, there we go. So we can't have all of these be 9, right? Because that doesn't work, because then you have a doubling in a row or in a column. You can't even have 3 9s here. So therefore, you can only have, at most, 2 extra high digits in the 2 by 2 corners. And they have to be 6 with 9, 6 when 1, 2, adding up to 9. So we only have 3 high digits, period, in the 2 by 2 corner. Sorry. We only have 2 extra high digits in the corners, and they have to be with 6 with the 1, 2, with 1, 2 adding up to 9. So we only have 6 high digits, so then this must be low, high, low, high, low, high, and low. So this is the same thing. Low, high, low, high, low, high, and low. So that means the 6s have to be here. So this is 6 next to 1 and 1. And these highs, so we have 1 and 1 here. 2 of them must be 9. So 6s cannot be here. So this cannot be 9 with 1 or 2. Therefore, where are the 6s in the corners? They have to be 9 here, with this being 1, 2, and 6. So we have 1, 2, 6 here. This must be 9 with 1, 2, and 6, because you cannot appear 6 here. So then we have 9 here, 9 here. That means as the highs, we don't know which. One of these is 9. What else do we have? Remaining digits in box 1 are 3, 4, 5, 7, 8. Same with box 9. Okay. This has to be 7 or 8. This is 7 or 8. And they could be the same digit. 9 cannot be here or here or here. So we know we need a 9 somewhere in... Okay. Where is the 9 in box 8? Cannot be here. Can't be on the Renban. Because again, we have a high digit here. And to have a 4-length Renban with 9 on it, it must be 6, 7, 8, 9, which would eliminate all possibilities for that cell. So 9 cannot be here. 9 can't be on the Renban. 9 has to be here, which eliminates 9 from being there. So 9 in box 7 has to be here, which means this cannot be 9. Again, 9 cannot be on the Renban here. Can't be here because of 9 in the column. Can't be here because 9 in the column. So 9 has to be here. That eliminates 9 being here, but it could be on the Renban this time. Except that this would be 7, 8, 9 as a Renban, and that would eliminate all possibilities for this cell, since it can't be 6. So 9 cannot be on the Renban here either. So no 9 here, no 9 here, no 9 on the Renban, so 9 has to be here. Which means 9 cannot be here, 9 cannot be on the arrow, 9 can't be here because 9 in the column, so 9 has to be there. So 9 again cannot be here, cannot be on the Renban because it would be 7, 8, 9, and that would eliminate all possibilities for that cell. So 9 can't be here, can't be on the Renban, can't be here, so 9 has to be here. Which means we have 8 9s, we know where the last 9 has to be, it has to be there. 1, where can 1 be? 1 cannot be here, cannot be here, so 1 is in the central box in this cell. That means this is 7 or 8 here, 7 or 8 here. We cannot have another high in this Fistemafel ring because there's no way to be in the 2x2 corners for another high. So it's 3, 4, 5. This can only be 2 or 3 here because it's next to a 7 or 8 on the Whisper 5 line. Same with that. Okay. For 4-length Renban, obviously cannot be 2, 3, 4, 5. Because that would eliminate all possibilities for that. Cannot be 5, 6, 7, 8, because that would eliminate all possibilities for that. So I think, okay, what are the possibilities? 3, 4, 5, 6, 4, 5, 6, 7, and those are the only possibilities. So 3, 4, 5, 6, or 4, 5, 6, 7. So we're guaranteed 4, 5, and 6 on this Renban. So 4, 5, and 6. So if this is 3, 4, 5, 6, this becomes 2. And we have 7 or 8 there. And then therefore this would be 7 or 8. If this is 4, 5, 6, 7, this would be 8 here. This would have to be 2 or 3, which would make 2 or 3 one of those. So those are the possibilities there. This, again, cannot be 2, 3, 4, 5. But it could be 3, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8. So we're guaranteed 5 and 6 here on this Renban. But do we have any other information? Not particularly. This could be 2, 3, or 4. This is 2, 3, or 4 also. Hmm. So this cannot be 2, 3, 4. It could be 3, 4, 5, 4, 5, 6, 5, 6, 7, or 6, 7, 8. Those are all possibilities. So there's nothing guaranteed on this Renban. If this is 7 or... Whichever 7 or 8 is here, that means this cannot be 7 or 8 here. Which means this digit, let's call it A, has to be one of these two digits here. So that means this has to be a different digit. So this must be B. So one of them is 7, and the other one has to be 8 then. That means B has to be one of these two here. So this cannot be A or B. So we are guaranteed this is 2, 3, 4, or 5. Because both 7 and 8s are accounted for. This can't be 2A or B. So this is also 2, 3, 5 here. So we are guaranteed a 1, 2, 4 to add up to 7. We don't know which one's A and we don't know which one's B, is the question. So we have in the corners a guaranteed 1, 2, 6, 1, 2, 6, and 1, 2, 4. And the other one must be either 1, 2, 5 or 1, 3, 4. So these are 1 through 5. These are 1 through 5. So then let's mark these as Z and Y. I don't know which one's which. That means Z has to be one of these two here, which means this can't be Z, which means Z is there. Y has to be one of these two, which means Y is one of those two. Yeah, that works. So Y is guaranteed to be, then, on this Renban. That means you either have a 7 or 8 there. So it's either then 6, 7, 8, 5, 6, 7, or 4, 5, 6? No. 6, 7, 8, or 5, 6, 7. Either way, you're guaranteed this has to have a 6 or 7 to be on this Renban, which eliminates 6 and 7 in the rest of the column. So this cannot be 6, it's 1, 2 as a pair, which means this cannot be 1 or 2, this is 6. This 1, 2 pair eliminates 1 and 2 as a possibility here. So there we go. This cannot be 1 and 2 here. This is guaranteed to have a 1. It has to be 1, 3, 4 to add up to 8. So then y has to be 8. So y is 8, which means z is 7. So then this must be 6, 7, and 8 here. So we have 6, 7, 8, which eliminates 6, 7, 8 in the rest of the column. This can't be z. This can't be, this has to be z. And z is 7. So this is 7 here, which eliminates 7 in one of these cells here. This cannot be 3 or 4 because of the 3, 4 pair in the column. Also, this can't be 3 or 4 because of the 3, 4 pair in the box. So this must be 5 here. That eliminates 5 from being here. This can't be 5 either. So we have a 3, 4, 8 triplet in box 9, which eliminates 3, 4, and 8 in the rest of the column. This can't be 3 or 4. This is 2. So 2 can't be here. Where is 2 in box 3? It has to be here. So that 2 eliminates 2 here. So this is 3. Therefore, B has to be 8. This is 3 and 8. Therefore, that forces this to be 7. This is 2 next to the 7. So this cannot be 7 here. This is 8. So we have, this is 3, 4, 5, 6, 7. Oops. I'm sorry, 3, 4, 5, 6. This is 1, 2, 4 as a triplet, which eliminates 1, 2, 4 in the rest of the box, so the no 2 or 4 here. This 3 eliminates 3 here. No 3 or 8, no 3 or 8. We have a 4, 5, 7 triplet. This can't be 7 because of 7 in the column. We have a 4, 5 pair in box 1, which eliminates 4 and 5 in the rest of the box. So this is 7. This cannot be 4 or 5 or 7, which makes this a 3, 8 pair. This 8 eliminates 8 here, so this is 3, which makes this 8. 3 eliminates 3 here, so it's 4 and 3. That leaves these digits as 5 and 7. This 1 eliminates 1 in the rest of the row, so this is 2, 6 as a pair, which eliminates 2 and 6 in the rest of the box. So this is 1, which eliminates 1 in the rest of the column, so therefore this must be 1 here. So this is 1, which eliminates 1 here, so that's 2 and 1. 2 eliminates 2 here, so it's 4 and 2. That means this cannot be 4 here. We have to have another 2 in this Fist and Mefel ring to match the 3 2s, so this has to be 2 here. We do not have a 5 in the 2 by 2 corners, and this 2 eliminates 2 here, so this is 6, which makes this 2. This 3 eliminates 3 in the rest of the column, so this is 5, which eliminates 5 here, so it's 4, which makes this 5. We have to have 2 4s available, and so this is another 4, which means this cannot be 4 here. Remaining digits in row 7 are 3 and 8. This can't be 8 because of 8 in the column, so this is 3, which makes this 8. This cannot be 4 and 6 here. This becomes a 3, 5 pair, which eliminates 3 and 5 in the rest of the box, so this is 4, 6 as a pair. 8 eliminates 8 here. This can't be 7 because of 7 in the row. Remaining digits in column 8 are 3, 4, and 5. We are guaranteed a 7 on this Renban. And we have 5 and 6. So you can no longer have a 3 here. Because if you have 3, that would be 3, 5, 6, 7, which is not consecutive. So 3 cannot be here. 6 eliminates 6 from being here. So the remaining digits in row 9 are 5, 7, and 3 and 8, but 3 can't be here. So this is 5, 7, 8, which eliminates 5, 7, and this must be a 6 here. That eliminates 8 here, so this is 3, that's 8. That leaves this as a 3, 4 pair. Remaining digits in row 1. We have guaranteed 4 here, and this is 5 or 7. 4 cannot be on a 3-length rim band with 7 because it's 4, 5, and 6 at most. So this has to be 4 and 5, which eliminates 5 here, so it's 7. This is 5. This can't be 3 because of 3 in the row, so it's 4, 5, and 6 as the ren band. Which leaves 2 and 7 remaining in row 2. Where is 2 in box 5? Can't be here because of 2 in the row, can't be here because of 2 in the row, can't be here because of 2 in the column. So 2 has to be here, which makes this a 3-4 pair. 3 eliminates 3 in this possibility, so this is 4, that's 3. 2 eliminates 2 here, so it's 7 and 2. 3 and 4 eliminate 3 and 4 here, so that's 5, which eliminates 5 in the rest of the column. That leaves this as 6 or 7, and this can't be 6 because of 6 in the column. So this is 7, which makes this 6. 3 eliminates 3 here, so it's 4 and 3. 6 eliminates 6 here, so it's 8. This can't be 6 or 8, it's 7. This cannot be 7 here. It has to be 5 and 8 remaining here. 8 eliminates 8 here. 7 eliminates 7 here. So where's 7 in row 9? It has to be here. This is 7. 4 eliminates 4 here, so it's 5 and 4. That leaves this digit also as 5 or 8, but it cannot be 8 because of 8 in the row. So this is 5, this is 8, which makes this 5, which makes this 8. 5 eliminates 5 here, so it's 3 and 5. 3 eliminates 3 here, so it's 4 and 3. 4 eliminates 4 here, so it's 6 and 4, which leaves this as a 6. I don't know if I would classify this as easy. Even with Fistimafel's ring knowledge, you have to have some other knowledge to deduce from this, and I don't think that's an easy way of deducing that. So I would not classify this as easy. I think I would put this. It's not quite challenging, but again, when I grade difficulty, I would put it slightly harder difficulty than put it a little too low, because I feel that, it would basically, I don't know. I'd rather make it grade it harder as a difficulty, and then people be pleasantly surprised versus having people be, oh, this is easy, and then finding it much more difficult than they think, right? So that's just my personal preference, though. Either way, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.